Okay, so yesterday we were talking about definition of limit of sequence, right?
Yes, sir.
So, xn is a sequence of real numbers a real number x is said to be a limit of sequence xn if given any distance from x we can find terms of sequence, right? So this is what we defined yesterday. Key x is limit of sequence xn if given any epsilon we can find k after that k all terms are in that distance from x. So from this figure it is clear given any epsilon, as we discussed yesterday's example, if you are going to if you are claiming that you are going towards particular point m, then how will you prove it? Right, so given any distance, you can produce your location which is inside that distance. So it should happen for every distance. Then we can believe that you are going towards that point, particular point. So same thing is for sequence. So given any epsilon from distance, epsilon distance from x. So what epsilon? So whatever epsilon you take, whatever distance, every time you can produce kth term. After that, all terms are in this distance. So if given any distance epsilon, we can produce k such that distance of the terms from x is less than epsilon after kth term. So definition is clear. Any doubt in the definition? Definition is clear.
Yes, sir.
Right. So if there is still confusion, so given any epsilon distance from x, I can produce k after k term, all terms are in this distance from. So if you look at k term and k plus first term, what is the distance of k plus first term and x? So this distance is certainly less than epsilon, right? Distance of k plus second term and x is less than epsilon. Right. So that is happen for all terms after kth term. Right, k is a natural number. Basically means k is a natural number means look at the corresponding term kth term. On all onward terms are in this distance epsilon distance from x. So that is what we realize from the yesterday's example. So for example, let xn is equal to 1 by n. Right, then what is limit n tends to infinity? So what is limit of sequence xn? Right, so we want to see what is limit of this sequence xn. So or prove that limit of xn is 0. That means this sequence going towards 0. So by observation also we realize that this sequence is going moving towards 0, right? But what is the clear proof that it is moving towards 0 or going towards 0? Because we cannot reach 0, but as n tends to infinity it is moving towards 0. So, so what I will do, so for example, if epsilon is equal to 1 by 10, then what is k such that, what is the value of k such that xn minus 0, right? What is x in this case? 0. X in this case is 0. So xn minus 0 is less than 1 by 10 for all n greater or equal this k. Right, so what is a k in this case? Do you understand? What should be the value of k in the definition of limit?
10.
Okay, so you said 10, but what is a 10 term? For example, what is x10 minus 0?
1 by 10.
So 1 by 10. Is it less than 1 by 10, which is our epsilon?
No.
No, right? And therefore, what should be the proper choice for k?
Greater than 10.
Greater than 10. Very good. So if k is equal to 11, 12, whatever, but anything greater than 10 will work, right? So if you select k is equal to 11 and then for n greater equal 11, n greater equal 11, is it true that xn minus 0, which is 1 by n minus 0, which is 1 by n, is it less than 1 by 10? For every n greater equal 11, is it true?
Yes.
Yes,
Yes.
sir.
So this is certainly true because, so this is true. So why this is true? Because if n is greater equal 11, then 1 by n is less equal 1 by 11, which is less than 1 by 10, right? So whatever n greater equal 11 you select, this is going to happen. Therefore, what is the conclusion? For epsilon is equal to 1 by 10, there exists k. What is k? 11, 12, no matter, because if something is true after 11, then same thing is true for after 12 also, right? Am I right? If something going to happen for every number after 11, so same thing is true for every number after 20,
Yes,
right?
sir.
So therefore k is not unique. Somebody may take k is equal to 11, somebody may take k is equal to 20, not an issue, because only point is, does there exist k, right? So there exists k is equal to 11, natural number. Remember that this is a natural number because k is the position. So k term. After k term onwards, all terms satisfy this condition. So there exists k is equal to 11 such that what is going to happen? So xn minus 0 is less than this epsilon for every n greater equal this k, which is 11. Right, here 1 by 10 is epsilon, here k is 11. So this is simple observation, but here I did for particular epsilon, but the single, if something is true for one epsilon, this definition hold for one epsilon, this is not sufficient, right? So if epsilon is equal to 2 upon 253, then what is k? So what is the number k in this case? Right? Understand? First I choose epsilon 1 by 10. Now I am choosing epsilon 2 upon 253. So what is the value of k? What is k? what is k such that, right? So what is k such that the distance of these terms from 0 less than 2 upon 253 for all n greater equal k. So this k onwards every term,
127.
right? What is k?
127.
So how do we guess, right? So what we want, see, think logically, and then we'll generalize this, right? So what we want, xn minus 0 less than 2 upon 253. That means 1 by xn is 1 by n, right? For every n. So minus 0, which is 1 by n is less than 2 upon 253. That means if you want to make this quantity xn minus 0 less than this number, that means what should be the n? N greater
2
than
upon 254.
253 upon 2. So what is 253 upon 2? 1, 2, 1, 2,
6.5.
6.
6.5, right? Very good. So therefore, what is the choice for k? Because if you want xn minus 0 less than this number 2 upon 253, then n must be greater than 126.5. And therefore, if once your n is greater than 26.5, then this is going to happen. So what is the proper choice for k?
Greater than or equal to 127.
So that we choose k greater than 126.5 because k is a natural number, remember that, and 126.5 is not a natural number, right? So let us choose k is equal to, so what is the very initial choice? What is a natural number which is greater?
127.
Right, 127 is immediate choice. Am I right? So 127 is immediate choice. You can choose 128, no problem. Now, is it the correct k? Now, question I would like to ask is this the required key? What do you mean by required key? Is this the k such that the distance of terms from 0 is less than this number? Which number? 2 upon 253 for every n greater equal k. Right? Is this the correct k? This is our guess, right? But is this the correct? So verify this. So to verify this, if n is greater equal this k, suppose I choose n greater equal k, but I know that my k is greater than what? What type of k I have selected? So I have selected k 126.5. Right? So I have selected k greater than this. And if n is greater equal this, so ultimately n is greater than 126.5. Am I right? So what is my k? K is basically k is, forget about, so k is 127. I have selected k 127. I have selected k is equal to 127. And when I say that n is greater equal k, that means n is greater equal 127. Then for any n, right? For every n, how many n's are there after k?
Infinite.
Infinitely many, right? 127, 128, 129, all after that. So then, so if n is greater equal 127, is it going to happen that xn minus 0 is less than this epsilon? What is it? What is xn minus 0 is 1 by n minus 0. But this is just 1 by n because it is non-negative quantity, right? So my n is greater equal k is 127, that means n is greater equal 127, and therefore 1 by n is less equal 1 upon 127, but 127 is less than 1 upon 127 is less than 2 upon 253. Is it true?
Yes, sir.
Right, so this is less than or equal to 1 upon 127, and 1 upon 127 is strictly less than 2 upon 253. So therefore, if n is greater equal 127, then xn minus 0 is less than 2 upon 253. Correct? For this particular epsilon, I found k is 127. Now, so from this, it is possible to produce k for every epsilon, right? So in general, if epsilon is given, so whatever is epsilon, can you tell me k? Then what is k? Do you understand the question? Understand the question? Question is ki for particular epsilon I can easily produce, right, k. What is k? But you understand one thing ki how I decided my k? I decided k from so how do I decide my k? I decided that key that n should be greater than 253 upon 2, that is 126.5, and then I realized that my k should be greater than this 253 upon 2. What is 253 upon 2? Is it 1 by epsilon? Because my epsilon was what?
Yes, sir.
252 upon
Yes.
253, and therefore I realized that my n should be greater than 1 by epsilon. Right. So therefore your k depends on epsilon. K depends on what? Epsilon. What is your epsilon? What distance? So if you recall the yesterday's example, you are going towards Mumbai, then you will produce a location. Are you are in this distance from M? What is the proof? You will send a location. But if you are given this distance, very small distance from M, then your location is a different, right? Which is in this distance from M. So your location or your k depends on what distance is given, right? So first epsilon is given, then are you able to produce k? Am I right?
Yes, sir.
Right. So therefore for whatever epsilon, can you give the formula? Can you generate the formula for k? Right. So suppose your friend will give you epsilon, immediately you will be able to produce k. So can you generate the formula in general?
So K should be greater than 1 upon epsilon naught.
Right. So given, so what we want k such that xn minus 0 less than epsilon for all n greater equal k. So this we want, right? That is, we want 1 by n minus 0 less than epsilon for all n greater equal k. That means what we want, 1 by n is less than epsilon. That means what we want, n is greater than 1 by epsilon. So for what n this is going to happen? So n is greater than 1 by epsilon. So what is the choice for k? So what is the choice for k? Thus, the appropriate choice for k is k greater than 1 by epsilon. So you choose any natural number greater than 1 by epsilon, right? So appropriate choice is, but remember that k is a natural number, is k belongs to n and k greater than 1 by epsilon. Now question I would like to ask, what is the guarantee? that there exists such key. What is the guarantee that there exists such key?
One by epsilon is a real number, and we have already proved by Archimedean property that there exists a natural number greater than a real number.
Very good. So, what is the guarantee? Archimedean property. Right. So, epsilon is a positive real number. 1 by epsilon is a positive real number. So, certainly there is a natural number greater than that. So, choose one of them as a k, and then for that k, after k onwards, the this is going to happen. So, is this clear?
Yes, sir.
Okay. So, this is exercise for you. Ki my sequence is xn is 1 by n and epsilon and k. So epsilon is 1 by 2, 1 by 20. So 2 upon 2553, right? 5 upon 7898, and find k. So k for epsilon. Right, so you do this exercise, and then in general also we have discussed, so this is not a difficult. So let us go to some non-trivial problem. This was easy thing, right? This problem, this sequence 1 by n was, in some sense it was simpler. So let xn is equal to 2n plus 3 divided by 5n plus 7, for example. Now prove that. Limit as n tends to infinity, xn is 2 by 5. Okay, so now I want to prove this, right? So what is our aim? What is our aim? What is our aim? Limit n tends to infinity, two by 5, right? So that is what we want. What we want. What we want.
Sir, hello.
Okay, so what we want.
Sir,
Yes.
sir, can we do this by multiplying 1 and then writing 1 as n into 1 upon n and using it to solve the given expression? Can we do that?
No. That we do not want at this level. That those are shortcuts. So we are going to prove that key this is
Okay,
allowed.
okay,
That process is allowed. That we are going to prove later on, and
okay, all right.
then we'll apply that things. Right.
Okay, okay,
Right now we are in the initial stage. Key how to prove that limit is this.
okay.
So what we
So
want.
we'll consider an epsilon, a distance epsilon from the number 2 by 5, and we'll prove that we can generate a natural number such that the distance of this sequence is less than that epsilon.
So what we want, given epsilon. So basically, logically, what we are doing, you are claiming that the limit of this sequence is 2 by 5, and somebody is not satisfied, and then you are going to prove ki, okay, you are not satisfied, so I will show you this is limit. And why you are some person, your friend is not satisfied means what? He will give you epsilon, right? You are claiming that ki this sequence toward this number x, right? x1, x2, and so on. You are claiming that sequence is going toward this number x, and some your friend is not satisfied. Then what you will say ki, okay, you are saying ki sequence is going towards x, then give me terms of sequence which are very close to x. Very close to x means what? He will give you distance from x, and then you will produce k. Ki look at the k term, and onwards all terms are in this distance. Okay, he is not satisfied, he will give you smaller distance. Then what happens? Then also you can produce some k. You look at this k, and this k, new k might not be same, but if this k is 10, new k might be 100, whatever. And you will say that look at this k, and k onwards look at the terms, all terms are in this distance, still he is not satisfied, you will give a epsilon. So for any epsilon, are you able to do this? Then your friend will be satisfied. So this is a logic, right? So is this clear?
Yes, sir.
So once logic is clear, rest of the job is very easy. The rest of the things are very easy if you understand this logic, what we are doing. So your friend giving you epsilon, and you are trying to produce k. That is the business, nothing else. So given epsilon, there exists k. What is k? Is a natural number such that the distance between xn and x less than epsilon for all n greater equal k. So that is what is xn here. What is xn here? 2n.
2n plus 3 upon 5n plus 7. 2 by 5.
Right. So we'll try to generate formula for k, and that do you understand that k depends on epsilon? Do you believe this? Do you agree?
Yes.
Yes, sir.
Right. Because if your friend gives you this distance, your k is something, but your friend gives you very small distance, then that k is not the right k, right? So that new k might be larger. After that, the distance is less than epsilon. So it depends on epsilon. So this we want. So how to start the business now? How to start the process? This is aim.
First, we'll solve the mod.
Yeah, means what? You are right, but how your job starts?
Selecting an epsilon.
So see what is philosophical it means. Suppose somebody asks you to bring a glass full water, right? Suppose somebody asks you bring the water. How will you start the process? So same logic, right? How will you start the process?
By taking a glass.
Yes. So your process starts with the glass. We'll pick up a glass, and then we'll try to bring the water. We'll search for water, right? So same philosophy. Our process starts with epsilon. So you are going to prove that limit is 2 by 5. So you will first ask you give me epsilon, right? And then I will produce delta. Whatever epsilon you give me, I will produce k, right? Do you understand what I want to say?
Yes, sir.
Right.
Yes, sir.
Yes.
So if you understand this, then the job will be very easy. So given epsilon, our process starts with epsilon. Now epsilon is given, so epsilon is known. So do you understand? Ki epsilon is now given. So your friend gives you epsilon. So what we want now our process starts. But what is in my mind? What is in our mind? We want to find k. such that xn minus x is less than epsilon for all n greater or equal k. Right, so this is a logic. See, and you need to understand that first epsilon is given. Your friend gives you epsilon, now your job starts to produce k. Right, so epsilon is known. So now remember that ki epsilon is a known quantity, and for this epsilon we want to produce k. Okay. So what type of k we want? So k should satisfy this condition, right? The distance of this thing from this less than epsilon. Such k we want, right? So therefore consider xn minus x. What is xn minus x? 2n plus 3 by 5n plus 7 minus 2 by 3. Simplify this. Try to simplify this difference so that I can guess. Right? So we are going to guess the k, and then we'll verify that k, okay, the k which I guess is correct. Right, so I will first simplify this expression which I want to make less than epsilon, and then I will guess k how to make this less than epsilon.
So
Sir,
it's
it's 2
minus.
by 5.
It's 5.
What is, oh, 2 by 5. Fine. So simplify this expression. So 10n plus 15 minus 10n minus what? 14. You correct me if I am making mistake in calculations. 5n plus 7.
Sir, there will be considered mod xn minus x.
Oh, right. Very good. Mod xn minus x. Right. What is it? So 10n cancels. 15 minus 14 is 1. So what is it? 1 upon 5 times 5n plus 7. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
But here don't no need of a modulus sign or absolute value sign. Why?
N belongs to natural numbers.
Yeah, we are dealing with natural numbers and this quantity is anyway positive. But I can say that this quantity is less than this, right?
Yes, sir.
Yes, sir.
This is a simple step because denominator is smaller, so quantity is larger. I just neglect 5, so whatever resulting quantity is larger. But still this quantity is 1 upon 5n is larger than this. Am I right?
Yes.
Right.
Yes.
So
So now what we started with what 2n plus 3 upon 5n plus 7, 5n plus 7 minus 2 by 5, and we came to this conclusion that this quantity is less than or equal to 5n. This is true for all natural numbers, no matter what natural number you select, right? This is going to happen, right? So thus, to make less than epsilon, if, because what is our ultimate aim? Our ultimate aim is to make this quantity less than epsilon, but right now we don't know whether it is less than epsilon for what values of n. So this would be less than epsilon if 1 upon 5n is less than epsilon. Am I right? Logically, is it clear what I am saying?
Yes, sir.
yes, sir.
So uh, note that this amount, if you which we want to make less than epsilon, but this will be possible if we can make 1 upon 5n is less than epsilon. That is if n is greater than 1 upon 5 epsilon. Am I right? Do you understand this?
Yes, sir.
Yes, sir.
Yes, sir.
Oh. Now can we guess what is the choice for K?
Should be greater than 1 upon 5 epsilon naught.
Right, very good. So choose. So thus choose K belongs to natural numbers with K greater than 1 upon 5 epsilon. And is this well defined value of K? Well defined means can we produce K? So S by Archimedean property.
Yes.
And epsilon is already given. Your friend, I have given you epsilon. And you know the epsilon. Epsilon is known quantity. Epsilon is in our hand. And then now, because if you pick up a glass and glass is in your hand, then certainly you can get the water. But your glass is not in your hand and you don't know how to bring the water, then the process is not well defined. Right, so glass is in your hand, that means epsilon is in your hand. Now you can look at 5 epsilon and take its inverse, and that is some number, and take natural number greater than that. Right. So now you should ask question yourself that is it the correct key? Is this the required key? Is this the required key? So verify this. Right? So try to verify. So how to verify this? When we believe that this is a correct key. How to believe that this is yes.
Xn minus x should be less than epsilon. So over there we can put n as 1 upon 5 epsilon and
Ah,
solve.
so verify that. So if n is greater equal key. So when we agree that key this is a correct key, when we believe that this is a correct key, if for every n greater equal k, check whether xn minus x, which is what is the numerator? 2n plus 3 upon 2n plus 3 upon 5n plus 7 minus 2 by 5, whether this quantity less than epsilon or not. But by previous calculation, I know that this quantity is same as 1 upon 5 times 5n plus 7, right? For all natural numbers, so for all n greater equal k, this is going to happen. So this is also less than or equal to 1 upon 5n by for all n this is true, and for n greater equal k certainly it is true. Now I am choosing n greater equal k, and what is my k? K I have selected natural number which is greater than 1 upon 5 epsilon, and therefore what is going to happen? 1 upon n is less than 5 epsilon. Am I right?
Yes, sir.
Right. So what k I have selected, and then n is greater equal k, certainly for such n. Right, if your n is greater or equal to for such n, 1 by n is less than 5 epsilon. So this is less than 1 upon 5 into 1 by n, but 1 by n is less than 5 epsilon, which is epsilon. So what is the conclusion? Thus, if n is greater or equal this particular k, then what? Xn minus x, or 2n plus 3 upon 5n plus 7 minus 2 by 5 is less than epsilon. So this is verified. Is it clear?
Yes, sir.
Right. So this is possible for any epsilon now. Right. We have 2n plus 3 upon 5n plus 7 is 2 by 5. So epsilon was arbitrary. Arbitrary means no matter what epsilon you select. Right. So this is 2 by 5, and what epsilon you select, you can produce k. All terms are here near in this distance. Right, so this in epsilon distance from 2 upon 5. Whatever epsilon you select, every time we are able to produce k. All terms after k are in this distance. So ultimately, what is going to happen? Terms are arbitrarily close to 2 upon 5. That means ultimately terms are going towards 2 upon 5. Okay, so logically the proof is clear.
Yes, sir.
Okay, now in particular, find k for epsilon is equal to 1 by 10, 1 upon 25, 2 upon 20, 2000, right? Epsilon is equal to 1 upon 3679. So can you immediately find epsilon for k for epsilon, these epsilons, various epsilons? Yes, right. We got a formula here. What is the formula for k? Just look at 1 upon 5 epsilon and choose natural number greater than that. That's it. Right? So you just find k for these epsilons. That is exercise. But in general, we have generated formula. So if you are able to generate formula for any epsilon, that means the sequence is converging to that, going towards that point. Right. So so if x is limit of sequence xn, then we write limit n tends to infinity xn is equal to x. Limit exists, exists and is, we say that the sequence xn converges to, right? So we say that sequence xn converges to real number x if for a sequence xn no such number exists, or if for a sequence xn no such number exists or limit does not exist, then we say that the sequence is divergent, is not convergent or divergent. Or not convergent. So if x is a limit of sequence, we say that sequence converges to x, right? So if such number does not exist for a sequence, then we say that such real number does not exist, then we say that sequence is divergent or not convergent. So let xn is equal to 2n plus 1 upon prove that the sequence xn converges to 2 by 3. this sequence converges to 2 by 3. So the procedure is similar. Can you produce k for epsilon? Right. So this is exercise. I will leave this as exercise. But point is, let now what are the terms of this sequence? What are terms of this sequence? What is the first term?
-1.
-1.
Right. So -1. Second term is
1.
1.
-1.
Right. In this way, terms are this. So prove that. Now, if you look at the terms of this sequence, where these terms are tending, where these term, are these terms going to settle at a particular point? Right. So if you look at this sequence 1 by n, then what is going to happen? 1, 1 by 2, 1 by 3, 0 is here. So 1 by 4, 1 by 5, and these terms are going to settle at what point?
0.
1.
0, right? In 1 by n case, in this case, the terms are going to settle at 0, and therefore we prove that limit is 0. But what is happening in this case? So term is -1, 1, -1, 1, -1, 1. Is it going to settle at a particular point?
No, sir.
No, right? And so what you can say that, what about limit of this sequence? Is it conversion?
It doesn't exist.
Right. So prove that
Divergent.
xn is not conversion. Or prove that does not exist. Right. So limit does not exist. So how to prove this?
Sir, we even cannot call it diverging also.
Why?
So because then the sum would be finite, no?
Which sum?
Sum of the sequence.
No, no. What is a divergent sequence?
Uh, till now we have learned that the one which doesn't have a limit.
Right. So the divergent sequence means limit does not exist. Yes.
Yes, sir. But what about the sum of the function then?
Which sum?
So if we consider a convergent sequence, then the sum of the elements tend to be finite, and when we consider a divergent sequence, then the sum would be infinite.
No, no, no. That is a different story. Don't get confused about this. So just uh, sum is a different thing. Don't think
They
about.
aren't the same, sir.
Hmm?
They aren't the same.
No, no, no. Not same.
Okay, sir.
So we'll see one by one. What is the meaning of divergence? Again, we can. Okay. So you want to think about this sequence. Xn is equal to 2n plus 1, for example. So what is the limit of this sequence? 2n plus 1 as n tends to infinity.
It does not exist.
Does not exist, right? But there is a difference between, so limit of -1 raised to n and 2n plus 1, both limit does not exist, but there is a basic difference between these sequences. So that is something what this is going towards infinity, 2n plus 1, but this is not going towards infinity, still it is not conversion, right?
Yes, sir.
Right. So that is what he was talking. There is some difference, but we'll see one by one. And remember that this divergent means limit does not exist. And again, divergent sequences are of two types. That classification. We'll see this later. So we want to prove that limit does not exist. Suppose limit exists, right? Then we'll get some contradiction and then we agree that the limit does not exist, right? Is it clear logically what we are going to do?
Yes.
Yes, sir.
Right. So let limit n tends to infinity xn is equal to L. Suppose it exists. Exist means it is a real number. When I say exist means it is in the real numbers. Why limit of 2n plus 1 does not exist? Because it is not in real numbers. It is outside the real numbers. So whatever it, that we do not believe because we cannot see outside the real numbers what is outside the real numbers. So exist means it is in the real number. So it is a real number L. Suppose limit exists and it is L. So by definition, of limit for epsilon is equal to 1. What definition of limit says if limit is L, right? What definition of limit says if limit is some number x or L? What definition says give me any epsilon, right? When you claim that limit is L or limit of sequence is this number, particular number L or x, whatever, then what you say intuitively, give me any epsilon, I can produce k, correct? So therefore, no matter what epsilon is selected, so every time you are able to produce k. So for this epsilon is equal to 1, there exists k such that xn minus L is less than this epsilon for all n greater equal k. So is this clear logically? Why I am choosing epsilon is equal to 1, that is a different thing, but whatever I have written, is it logically correct or is there any flaw?
Yes, sir, correct.
Right, because when I say that limit is L, no matter what epsilon I can produce k. So in particular I am choosing epsilon is equal to 1. For that epsilon also there is some k, so that k I am talking about. Right, but what is xn?
Minus 1 raised to n.
Right, and what I am saying now, my k is this, and then k plus 1, k plus 2, and so on. What this says k onwards you choose any number. For that number n, this is less than epsilon. Right, this is the previous step says. So in particular, if n is greater than k and n is even, does such n exist?
Yes.
Then for such n, okay, I will call it as n naught because I am choosing specific n naught which is greater than k and it is even. Then what is minus 1 raised to n naught minus L? Is it less than 1?
Yes, sir.
Less than 1. But I am choosing n very specific which is even. So what is minus 1 raised to n naught?
1.
1 minus L is less than 1. Right. That means minus 1 less than 1 minus L is less than 1. Because I have chosen specific n. So no matter now I am not varying n naught. N naught is specific even number I have selected. So okay, let me add one more step here. So
Sir,
yes.
and not is even, are we taking it so, or is there a reason?
Yeah, due to some reason so that I can get some contradiction. Because what is my previous statement? Ki you choose any n greater equal k. This quantity is less than 1, right?
Yes, sir.
Correct. And therefore I will select even one of. So there are many, but I will choose one of them, which is even. Then also this is true because I am saying that it is true for all. Then I will choose one of them. Then it is true for that particular n, and I am choosing n naught, which is even, which is greater than k, right?
Okay, sir.
Now just use the property of absolute value. So 0 less than L less than 2. This is first. Similarly, when I am saying that all n greater equal k, so if I choose n1 greater than k and n1 is odd, then is it true that ki minus 1 raised to n1 minus L is less than 1? Is this true?
No.
Why not? Because I have chosen n1 greater than k.
Because
And
if we solve the inequality, it won't be in,
no, that is a later thing. This argument we can make later on. But is this whatever I have written is correct, or is it correct? Because when I
yes, it
say
is correct according to our assumption.
right, because I am saying ki for every n greater equal k, this is going to happen less than 1. So if I choose the odd number greater than k, then also it is true. So I have chosen particular odd number n1. Right, but what is minus 1 raised to n1? Right, correct. Right, that means correct. That means minus 2 less than L less than 0. This is second. And therefore, if you assume that limit is L, then what is a contradiction? From 1 and 2. From 1 and 2, L is greater than 0 and L is less than 0. So contradiction. Right, so what 1 says L is positive and what 2 second says L is negative. So this is not possible for a real number which is positive as well as negative. Hence, limit n tends to infinity minus 1 raised to n does not exist. Okay, so this is clear.
Yes, sir.
Yes, sir.
Right. Therefore, we get contradiction